Hi, now I am going to make one short video on alternating current chapter. Okay, right. In this, listen very carefully. Our chapter name is alternating current. Is my voice clear? Yes or no? Once check yourself. Yes, is it clear? Hello, hello. Okay, right. Now I got it. It is clear now. Now going to start the class. Our chapter name is alternating current. Alternating current. This is very important chapter. From this chapter, in the exam, you will get either 3 marks or 5 marks question. Listen very carefully. There are 5 very important topics are there based on alternating current chapter. Okay, alternating current means what first? What is alternating current? Alternating current means this current value varies with the time. Alternating current. Alternating current means the current whose magnitude changes continuously. The current whose magnitude changes continuously. Current whose magnitude changes continuously. And direction changes periodically. And direction changes periodically. Is called as alternating current. I will explain the definition. What is this alternating current? Alternating current means alternate means it always changes. Okay, the current whose magnitude changes continuously. The current value is always changes. Magnitude means value means value. The value of current is always changes and direction also changes. Then such current is called as the alternating current. In our household purpose, we are using the current that is alternating current only, right? The symbol of the alternating current source, symbol of AC source. What is the symbol of AC source? Symbol of AC source is this one. This is the symbol of AC source. This said, here we can write, we should not indicate the positive and negative signs at here. Why we cannot indicate the positive and negative signs? These signs will be changes with the time. That's why we can write, we cannot write any plus minus for this. Okay. And AC source voltage, if you want to write the AC source some voltage, we can write the AC source voltage like this. AC source voltage. If we draw the graph between the voltage and current time or the current and time, we will get like this. For example, the voltage is taken on y-axis, AC voltage, Okay, AC voltage is taken on y-axis and the time are taken on x-axis. And if you draw the graph, you will get like this. It will be very sinusoidal, like sine graph you will get. That means what? The voltage value increases and become maximum, next decreases and become zero, oppositely increases and become maximum, oppositely decreases and become zero. Like this, voltage value continuously changes and voltage direction also changes, right? Then such voltage is called as alternating voltage. Alternating voltage graph will be like this there. That means AC source voltages graph we will get like wave. That wave equation we can write in terms of sine or cos. Then for the purpose here, AC source voltage generalized equation we can write as V naught sine omega t is equal to V naught sine omega t. What is V naught at here? V naught is the peak value of voltage. What is V naught? Peak value of voltage. Peak value means what? Maximum value of voltage. This is the peak value of voltage, right? This is the peak value of voltage. What is omega? Omega is the angular frequency. Angular frequency of AC source. Angular frequency means what? Angular frequency we can write omega is equal to 2 pi by capital T also we can write, or reciprocal of time period we can write as the frequency, where mu is the frequency of we can write the mu as okay frequency of AC. In India, the frequency of AC is 50 hertz in India. Okay, frequency means what? Number of cycles per second. Here this is called as the one cycle. This is called as the one cycle. Like this, how many cycles are producing in 1 second? That means how many times voltage increases become maximum, next decreases to zero, next oppositely increases become maximum, next oppositely decreases to here one cycle. Like this, how many cycles are producing in 1 second? That is called as the frequency. Frequency is the number of cycles per second, number of waves per second. T is the time period. T is the time period of wave. Time period of wave. Next, how many terms are there? Omega completed. Small t is the time. Small t is the time we can write. Small t we can write as time. These are the terms which are present in the AC source voltage. Okay, the AC source voltage this time, for example, like this it will be changes. Firstly, if it is like this, for example, AC source, if you supply to some bulb, then it will be happens like this. First, the current this will become positive and this will become negative, and the current increases in this circuit. Next, current decreases and become zero, and this sign will become the negative and this sign will become the positive. The current again direction changes now, and the current increases and next decreases to zero. Next it will become the plus and minus. Like this, alternating current means always the positive and negative terminals will be changes. The direction of current will be changes and the current value also changes, right? That means we should not fix the positive and negative signs because it is a alternating current. But the DC source we can symbol we can write like this. DC source, this is the positive and negative. It is a fixed voltage. Its voltage does not changes with the time. But AC source means AC means alternating current. Alternating current means its value changes continuously. Alternate current value changes continuously, right? And this is about the AC current, AC voltage. Now if you want to write the AC current formula, AC current formula we can write like this. This is about AC voltage we got. Here AC current, if you want to write like this we can write. Okay, listen very carefully. If you have any query, write in the chat box. AC current I want to write. AC current we can write like this. AC current I is equal we can write as I naught sin omega t plus phi we can write. Plus or minus phi we can write. This is the current. What is I naught in this? I naught is the peak value of current. Peak value means what? Maximum value of current. Peak value of current. Okay, omega is the angular frequency, t is the time, and phi is what at here? Phi is the phase difference. Phi is the phase difference between current and voltage. Current and voltage. Phase means what? Angle only. This omega t is the voltage angle. Omega t plus phi is the current angle. Angle difference omega t plus phi minus omega t. That phi is the phase difference between the current and voltage. Okay, students. Right now, let us go for the next continuation. Now I am going to start the important topic. Till now I gave just introduction for you, and now first important question we are going to start. This first AC is applied to the AC through resistor. I am applying the AC for a resistor. Then I want to derive the current formula through the resistor. Okay, this is the first topic that I am going to explain now, and this is a resistor. This is a resistor. For this, I am applying the AC source. I am applying the AC source. If I will apply the AC source at here, then here some current will be flows at here. At any instant, the current value always continuously changes. At any instant, the current we can consider as I. Now we can write the voltage source. Source voltage we can write as V naught sin omega t. Okay, right. And alternating voltage source we write as voltage source, AC source voltage we can write as the V, and the voltage across the resistance we can write as V suffix R. Okay, AC is applied for the resistor. Now we can write from figure, that is I think it may not clear it here. Once I will repeat this one. Okay, students, and due to the technical problem, network problem I am facing in my quarter. You see here, and this is the AC source. AC source voltage is V naught sin omega t, and here resistor across voltage is VR, and AC source we are applying to the resistor. The AC source voltage we write as V equal to V naught sin omega t, and then source voltage we can write V naught sin omega t. But from figure, voltage across AC source equal to voltage across resistance V equal to VR we write. B we write as the AC source voltage V naught sin omega t. Voltage across resistance we write as IR, because through the resistance the current is I. Okay, voltage across resistance is V suffix R is equal to I into R according to Ohm's law. Then I want, then R to take into left side, then V naught by R into sin omega t. V naught by R we write as I naught. I equal to I naught sin omega t we will get. This is the current at any instant of time. Current also varies with the time. Voltage also varies with the time. That's why it is called as alternating current and alternating voltage. You should follow the cursor. Right? This is the peak value of current. Now, I want the phase difference between the current and voltage. Phase difference between current and voltage in resistor, right? Across the resistor, what is the phase difference between the current and voltage? Voltage angle is omega t, current angle is also omega t. The phase difference means phase difference. Phase difference we will get as omega t minus omega t, we will get as 0. No phase difference, right? Phase difference means angle difference. There is no angle difference between them. The phase difference we will get as 0, right? In the resistor, right, there is no angle between the voltage and current. And the next one is, let us go for one thing. The phase difference between the current and voltage is 0. That means the phase difference also gives the angle between the current and voltage. Angle between current and voltage is also 0. Then before that, I am going to explain one thing. That is the next topic is the phasor diagram. Very important. Okay, in the exam there is a chance to ask based on this. Right? Listen very carefully. Phasor diagram. What is phasor diagram? Phasor diagram means what? Phasor diagram means representing the diagrammatical representation. Okay, representing the current and voltage as rotating vectors. We have to indicate the current and voltage as rotating vectors. Rotating vectors in anti-clockwise. If you indicate the current and voltage as rotating vectors in anti-clockwise, then such diagram is called as the phasor diagram. We will draw the phasor diagram at here. This we will take as the x-axis and this we will take as the y-axis. Now let us see if we will draw the voltage. Voltage is the V. This is the V voltage. Okay, this length gives the amplitude. Voltage is making some angle at here. The angle we can take as the omega t. Okay, V equal to V naught sin omega t. Voltage angle is omega t. What is the current angle? The current angle is also omega t. That means the current is also indicated, right? That is the current angle is omega t. That means the voltage and current both are along the same direction in the resistor. Okay, voltage and current are along the same direction in the resistor. This is only called as the phasor diagram. Just it is they are indicating the voltage and current as rotating vectors. Otherwise, we can also show like this. That is the both should be along the same direction. Angle difference will be 0. Voltage across resistance we can write as VR, and current is also this side only there. The current is I, but the current length, voltage length is more and the current length is less. Why the current length is less? Because current is you will get by dividing the its voltage with resistance. I equal to V. When time is 0, the voltage also 0 you will get. When time is 0, the voltage also 0 you will get. Okay, when time is 0, voltage 0 you will get. That means we can write like this. When time 0, voltage 0 you will get. You write here T0, voltage also we are getting 0. That means when time is 0, voltage 0. 0 comma 0 onwards it will starts. The graph will be like this, it will be there. This is the graph. If we draw the graph for the voltage, this is for the voltage versus time. If you want to draw the current graph, this is the current versus time equation in the resistor, right? Current angle is omega t, voltage angle also omega t, right? But the current value, current we will take this one, and if you draw the current t equal 0, if you write here sin 0 you will get sin 0 value 0. That means when time 0, current also 0, you will get the graph like this. This is the current graph and this is the voltage graph. Okay, this is about AC through resistor. AC through resistor. Next, AC through capacitor I want to write. Okay, AC through resistor. Any doubt, students? This is the current equation and this is the voltage graph. But in this current graph is current peak value of current is less than the peak value of voltage. Why? Peak value of current is equal to voltage by resistance. That's why the peak value of current is always less than the peak value of voltage. This is the peak value, highest value of the current, and this is the highest value of the voltage, right? The highest value of the voltage. This is the highest value of current. This is I naught, and this is the V naught. V naught value is more than the I naught. This is about AC through resistor. I think I am getting the signal problem in the night. I'm not getting the good signal at here. Due to that, in the middle, some breaks are occurring at here. Next, AC through inductor, I am going to explain. AC through inductor. These phasor diagrams are very important and phase difference is very important. Okay, AC through inductor. First, AC I am applying for the inductor. Then we have to derive the formula for the current in the inductor. This is considered as the inductor, and its inductance is L. And here I am connecting to AC source at here. The AC source voltage we know as V is equal to V naught sin omega t. And then the current starts from here. Some current flows at here. That current is we can take as I. Current we can take as I. Now AC source voltage is what? AC source voltage we write as AC source voltage, it will not change as the source voltage. That is always V equal to V naught sin omega t. This is equation 1, where V naught is the voltage at any instant of time, that is the instantaneous voltage. V naught is the peak value of voltage. Why it is peak value? When sine value is 1, then the sine maximum value is 1. When sine is 1, then the V equal to V naught you will get. That is the peak value of voltage. Peak value of voltage. And then next we will go for the omega. Omega is the angular frequency, T is the time. Voltage value varies with the time, that is the alternating voltage. And now let us see, here we are applying the voltage to the, this is AC source voltage that we are applying to some inductor. Inductor across the voltage we can take as the VL. Inductor means what actually? Inductor means just here you take a insulated copper wire that is wound like this, and this is called as a inductor, right? Just like a solenoid we can take as an inductor. When current passes through this inductor, when the current passes through this inductor, some EMF induces across this due to the self-induction. The induced EMF across this one we can do from Faraday's law, that is minus d phi by dt. And here we write as, we know according to Faraday's law, flux we can write as L into I. In L we can take outside, minus L di by dt we write. Induced EMF or the voltage across the inductor when I current passes is L di by dt. And now from figure we write voltage across AC source. This is the voltage across AC source V. Voltage across inductance, both are equal because they are in parallel. And voltage across AC source we write as V naught sin omega t. And VL, voltage across inductance, we write as L into di by dt. From the only magnitudes we have to write. Okay. If you have any query, write in the chat box. Okay. Next, we have to simplify. We have to derive the current formula in inductor, because actually AC source voltage does not changes, but the current value in different instruments different it will be there. So we have to derive the current formula for that. L. Okay, I am facing the continuous network problem. I will close the lecture also fastly. V naught by L integration sin omega t we write as the minus cos omega t by omega we can write. And this we can write I is equal to V naught by L omega into minus cos omega t we write. And minus cos omega t we can write as V naught by L omega we can write as XL. Minus cos omega t we write as sin 90 minus theta we write. Then 90 minus omega t we write. This minus we can take inside. Then we will get as I is equal to V naught by XL into sine of omega t minus 90 we will get. This XL by V naught by XL we can take as I naught. Then we can get as I is equal to I naught into I naught into sine omega t minus 90 we can write. Okay. Is equal to I naught sine omega t minus 90 we can write. This is the equation 2. equation 2. This is the current equation in the inductor. Okay, if we do look this equation, current value angle is 90 degree less than the voltage angle. From equation 1 and 2 we write like this. In this first, what peak value of current we can write? What is the formula for the peak value of current? Peak value of current in the inductor we write as I naught is equal to V naught by XL we write, where XL is what? Okay, what is XL at here? XL is the inductive reactance. XL is the inductive reactance. Inductive reactance. We write XL formula as L omega. Okay, inductive reactance means what? Is the resistance of inductor for the flow of AC. Okay, and if we draw the graph between the XL and omega, if you take the XL on y-axis and omega on x-axis, you will get like this. Okay, and this is the inductive reactance. Inductive reactance means resistance offered by the inductor for the flow of AC. Inductor resistance, that means the peak value of voltage by resistance gives the current, right? From equation 1 and 2 we write one thing, that is from equation 1 and equation 2 we say that first we find out the phase difference between current and voltage. Phase difference between the current and voltage in inductor. The phase difference, how we will get here? We have to subtract the both of them. Voltage angle is omega t from equation 1. Current angle is omega t minus 90. We write angle difference as omega t minus omega t minus 90. We will get as the angle difference as 90 degree. The phase difference we will get as 90 degree. Okay, right. Here we got the phase difference as 90 degree. In this one important point I have to explain for you, that is, you see here in inductor we have to write some points at here, very important points we have to write. In inductor what happens? In inductor, current lags voltage by 90 degree. Current lags by we are telling, from equation 1 and equation 2. You see the equation 1. In equation 1 the voltage equation is V naught sin omega t, right? In equation 2 current equation is the I naught sin omega t minus 90. That means the current equation is 90 degree less than the voltage angle. Current angle omega t minus 90 degree. Voltage angle is omega t. Current angle is 90 degree less than omega t, right? Less than voltage angle. That's why we can say that current lags voltage by 90 degree, or we can also say that voltage leads current by 90 degree in inductor. We have to draw the important diagram, that is the phasor diagram. How we can draw the phasor diagram? In the phasor diagram we have to represent the current and voltage vectors. We have to draw them as the rotating vectors. Let us consider this is x-axis and y-axis. Just we will take this as the voltage. The voltage angle is we can take as the omega t. Okay, this is the voltage. Then what about the current angle? The current angle will be like this. It will be there. This is the current direction. The current value is less than the voltage, and the current angle we will get as this angle. This angle we will get as 90 degree. This is 90 degree, and this angle we will get as omega t minus 90. Okay, current is rotating in anti-clockwise, voltage also rotating in anti-clockwise, but voltage is rotate more than the current. That is, voltage is in forward and current is in backward. When they are going like this voltage is going forward and current is going back. Means voltage leads the current, we can say, that the current is back of voltage, we can say. We are indicating the current and voltage as and rotating vectors in anti-clockwise direction here. Okay. Next, this we can also say draw like this. This is the phasor diagram is very important here. How we are drawing this diagram is very important. You see here, for example, here voltage angle we have the omega t, current angle we have the omega t minus 90. Okay, you take voltage angle. Voltage we are taking like this now. This is the voltage angle we are taking. Okay, current angle should be less than 90 degree. You subtract the 90 degree from the voltage angle, you will get the current angle. I will draw that clearly once again. After erasing, you will understood at that moment. This is the voltage angle. Voltage is making omega t degree. The current is this side now. This is the direction of the current, and the angle between the voltage and current. This angle is omega t minus 90. Current angle is omega t minus 90, and this extra angle we take as the 90 degree. This angle is the 90 degree. Okay, you see here current angle how much it is? Omega t minus 90. Okay, current angle is omega t minus 90. I equal to I naught sine omega t minus 90. Current angle is omega t minus 90. Voltage angle is what? Total omega t angle. You take the current angle is omega t minus 90. This one is the current angle, and this extra 90 you added here for the, if you add, then you will get omega t. Omega t is what? Voltage angle. That means you, this is the voltage angle. This is omega t minus 90. Further you add the 90. You will get the total omega t minus 90 plus 90 omega t you will get. Right? The voltage angle is omega t. Current angle is omega t minus 90. The current is back of voltage while rotating in anti-clockwise direction. Right? That we say that the current lags voltage by 90 degree. Okay. This diagram we can also draw like this. Voltage across inductor we can take like this. This is voltage across inductor. This side we can take as the current. Now the current is the back of voltage, right, by some angle 90 degree. The angle between the voltage and the current is 90 degree. Here we got the phase difference as 90. Phase difference gives the angle between the voltage and current. Okay, one topic I will tell and I will close. Okay, because of network problem, I don't want to continue. Next one is the AC through capacitor. I will tell and I will close. AC through capacitor. If you connect the AC to the capacitor, then what happens? Just you see here, this is a capacitor. Capacitance is a C. And here I am connecting the AC source to the capacitor. AC source symbol, we know that this is the symbol of the AC source. This is the symbol of AC source. Here we write the AC source voltage like this. V is equal to, we write as V naught sin omega t, we write. This is the AC source voltage. At any instant of them, charge stored on the capacitor we can take as a Q, and voltage across capacitance we write as V suffix C. But from the figure, the voltage across AC source should be equal to voltage across capacitance because they are in parallel. From figure we write like this: voltage across AC source equal to voltage across capacitance. Voltage across AC source formula is V naught sin omega t. Voltage across capacitance we write as V is equal to Q by C because we know as capacitance formula is C is equal to Q by V. From that, V is equal to Q by C we write. This is the voltage across capacitance. This is the V suffix C, right? V suffix C. And here we can write the Q formula, that is C V naught sin omega t. And here we got the instantaneous charge at any instant of time, and differentiate on both sides with respect to time. Now the differentiate above equation with respect to time. If we differentiate with respect to time, then what you will get? Current we will get. Current is equal to, we will get as dq by dt, right? And then we write as d by dt of q is what at here, cv naught sin omega t we write. And here we write the current is equal, cv naught is outside we have to write because they are a constant, and d by dt of sin omega t we write. But the sin omega t we write is, sin omega t differentiation formula is omega cos omega t. Sin omega t differentiation is cos omega t, and omega t differentiation is omega. Then we will get like this. This is V naught into C omega into cos omega t we write. This we write as the cos omega t. Little we will change this equation, V naught by, we write as the 1 by C omega into cos omega t, cos omega t. This we can write V naught by voltage by, this denominator is said to be resistance. Current equal to voltage by resistance. This resistance of the capacitor. Resistance of the capacitor we can call it as capacitive reactance into cos omega t we write as cos omega t only. And finally we are getting one equation, that is I is equal to, we will get as I naught cos omega t we write. And this we will change like this little, and I is equal to, we write as I naught into sin omega t plus 90 we will get. That means here we are getting the current equation. Okay, current equation is omega t plus 90. This is equation 2, right? And now here peak value of current is what? Peak value of current. Peak value of current is I naught. I naught is equal to, we write as P naught by XC. Okay. And here we write XC is the capacitive reactance. Capacitive reactance. Capacitive reactance means resistance offered by the capacitor for the flow of AC. For the AC, how much resistance capacitor offering? That is called as the capacitive reactance. Its formula is 1 by C omega. Capacitive reactance XC formula is 1 by C omega. Now, if you see this equation, in case of inductor, we got here current equation is omega t minus 90. In case of capacitor, we got I omega t plus 90. If you connect AC to the resistor, we got only omega t. Right here, the current angle is more. Current angle is more than the voltage angle. Voltage angle is only omega t, but the current angle is omega t plus 90. Let us see here. Let us discuss some more thing regarding this. Right? And you see here, from equation 1 and 2, we write like this. What we have from equation 1 and equation 2, that the current equation is V, voltage equation we write first. Voltage equation is V equal to V naught sin omega t. This is equation 1, and the current equation is I equal to I naught sin omega t plus 90 we can write. Okay, right. Now what we have to do it here, if you find out the phase difference, angle difference at here, 90 degree you will get. current angle is more. If you want to draw the graph phasor diagram, or if you want to find out the phase difference first, phase difference between the current and voltage, phase difference between current and voltage, how much phase difference you will get? The difference means angle difference, that you will get as omega t plus 90 minus omega t. Again the phase difference is 90 degree, but there is a little difference is there for the previous case and now. In the previous case minus 90 omega t, current angle is less, and omega t voltage angle is more, but here the current angle is more. That's why we say that the current leads voltage by 90 degree, current angle is more by 90 degree. Right here, if you want to draw the phasor diagram, we will get like this. Phasor diagram, if you want to draw, the phasor diagram will be like this. You will get, you see here very carefully, the phasor diagram you will get like this. You phasor diagram means you have to indicate the voltage and current as rotating vectors. You take the voltage and current. Current angle is more. I am taking the voltage angle as omega t. This is the voltage angle, and the current angle is more by 90 degree, right? More by 90 degree. This is the voltage angle, and okay, at the peak value of voltage, the maximum value of voltage is V naught. Why we got like this? When the initial time is zero, voltage also zero, because this is the graph for the voltage V is equal to V naught sin omega t. Voltage graph will not change, but the current will be changes. Now current equation what you got here? Current equation we got as I equal to I naught sin omega t minus 90 sin omega t plus 90 we got. If you write t equal 0, if you write I equal current we got as I naught sin omega t plus 90. That means if t 0 if you write, then you will get as I equal to I naught t 0 plus 90 we will get. Then we will get as I naught you will get. That means at starting some current will be there, right? Then we will get like this. This is the equation of the current. This is the equation of graph for the current. Okay, like this we have to draw the graph. And what is that? We till now we discussed about the AC through inductor, AC through capacitor, AC through resistor. In the AC through inductor, what happens? AC through capacitor, what happens? AC through resistor, what happens? In the AC through resistor, right? In the AC through resistor, okay. Once we can summarize everything. Note: you go for AC through resistor. In case of resistor, the voltage equation is V equal to V naught sin omega t, and the current equation is I is equal to I naught sin omega t. Angle difference, phase difference is we got as phase difference we got as angle difference omega t minus omega t 0. No phase difference means angle between V and I also 0. Angle between V and I is 0. Phase difference is nothing but angle between V and I only. That is 0. That means if you draw the phasor diagram, you will get like this. That is the voltage across resistance and the current. Both are along same direction with the same angle they are there. This is about the phasor diagram. Right? If you go for the inductor, if you go for the inductor, if you go for the inductor, V is equal to, we will get as V naught sin omega t. In everything, the voltage equation is same, but the current equation we write as I equal to I naught sin omega t minus 90 we will get omega t minus 90. Current angle is less than the voltage angle. Here we write current is in phase with the voltage. Current is in phase with voltage. Right? That means both are along same direction. No phase difference. Right? Here the current angle is less. Here the phase difference we write like this. phase difference between the current and voltage. Here we will get, you should write the phase difference, angle difference here. Omega t minus omega t minus 90 we will get. Then here the phase difference you will get is the 90 degree. Okay, phase difference you will get is 90 degree. And if you draw the phasor diagram at here, you have to draw like this. That is, the current angle is less, voltage angle is more. If you add the current angle is how much here, omega t minus 90 is the current angle. You add the 90 degree, then you will get the voltage angle. I am taking the current angle is like this. This is the direction of the current, and the current angle I am taking is omega t minus 90. Current angle I am taking is omega t minus 90. You add 90 degree, then you will get the voltage direction. You, this is the 90 degree, omega t minus 90 plus omega 90, you will get as the voltage. This is the phasor diagram. This is the voltage across inductance. In this we are indicating the current and voltage is rotating vectors in anti-clockwise direction. This is the phasor diagram. In this, voltage is, current is back, current angle is less, current is, voltage angle is more. We write that here current lags voltage by, current lags, current lags voltage by, current lags voltage by 90 degree. Current is lagging, lagging means back, 90 degree in inductor, in inductor, right? Okay, now what about the capacitor? What you got the equations, but in everything the voltage equation is the same. In case of capacitor, if you write the voltage equation, the voltage is again V equal to V, write as V naught sin omega t. If you derive the current equation, you got the current equation as I equal to I naught sin omega t plus 90. Means the current angle is more than the voltage angle. Current angle is more than the voltage angle. Okay. And when the current angle is more than the voltage angle, if you find out the phase difference again, you will get as again 90 degree phase difference between current and voltage. Phase difference between the current and voltage you will get as 90 degree. Okay. Now if you draw the phase, this one, you will get like this. I am taking the, what I am doing, current angle is more than the voltage angle, right? And I am taking the voltage angle. This is the voltage angle. Voltage angle is how much? Omega t. This is the voltage across capacitance. The current angle is 90 degree more, right here. This is the direction of the current. The current angle is 90 degree more. You add the 90 degree. More than this we see, plus 90 I am adding. Then you will get the current one. Here we are indicating in these as rotating vectors in anti-clockwise. Current angle is more. That's why we say that the current leads. Current leads. Current leads voltage by 90 degree. Current leads voltage by 90 degree in capacitor we write. Okay, in capacitor. Here we write the current lags 90 degree, that current is back of voltage by 90 degree, or the voltage is leads the current by 90 degree. Here current leads which is moving forward in anti-clockwise direction, right? आगे कौन है, पीछे कौन है? आगे करंट है इन कैपेसिटर, पीछे वोल्टेज है. वोल्टेज इज, voltage lags current by 90 degree, or current leads the voltage by 90 degree, we can write. Okay, this is the AC through resistor and inductor and capacitor, very important topics. And the current equations we have to derive by supplying the AC to the resistor, inductor and capacitor. Okay students, thank you to all. Hi.